All right, onward to lecture 19, part C. So in the previous two parts, we basically talked about the structure of an atom, right? And the important thing is we've learned that in the outside of an atom, there's these shells, which we can sort of imagine as rings around the nucleus where the electrons are going to exist. Now, what we're going to do in this part is we're going to talk about, well, in an atom, exactly what rings, what shells have electrons in them, and how many electrons are in a specific shell. Now, why on earth do we care about this? Well, because it turns out if you understand what shells have electrons in them and how many electrons are in a certain shell, it's going to help us understand how atoms behave, and especially in our next sort of topics, how atoms combine together to make molecules. So if you want to understand the behavior of an atom, you really got to know how are the electrons arranged in an atom. All right, so we're about to get to that, and the thing I need to tell you a little bit more detail about these shells, and then we're going to look at how electrons go into these shells and how that affects the properties of atoms. All right, so let's move on. Let's flip over, and we'll get into it. All right, so what have we talked about so far? So about 100 years ago, not even 100 years ago, this guy by the name of let's try Niels Bohr, kind of got tongue twisted there. Niels Bohr came along and he said, hey, do you know what an atom's like? Well, we already knew there's this nucleus of the atom, and then around the nucleus, there's these rings, these shells where electrons are found. I'm going to kind of draw that. I may not draw an entire circle just because I don't have a lot of room, but there's like the closest in ring that he called shell number one. You can imagine that circle, it keeps on going around, right? Like that. All right, and then there is a shell number two. And then, they keep on going. Shell number three, the third further away ring, and then you go a little further away, there's ring number four, shell number four. So, this was a great idea because it could explain like how we get different colors of light from elements and where that light is coming from. We just talked about it, right? Electrons moving between these shells. Now, just because you come up with an idea, even if it's a great idea, that doesn't mean that's the end of it, right? People are going to come along and they're going to try to improve on your idea. And what people discovered as they kind of worked on this idea is that these rings that he had numbered 1, 2, 3, and 4, they're actually made up of smaller rings. So for example, if we look at the second ring, there's not just one part to it. There's two parts to it. So there's actually another ring that's kind of close to the first one. And so to tell them apart, instead of just calling them shell 2, well, there's two parts to it. So you call the first part is called the S level, 2S, and then you get to the 2P level. So the numbers, these are our shells, but it turns out shells are made up of smaller regions, which are called subshells. All right, now that's true for the other parts as well. So for the other part, for the third shell, for example, it's actually made up of 3 parts. So the third shell has actually got 3 shells within it. There's 3 rings. So the first one he called the 3S, and then the next one's called the 3P. And then if you go a little further away, it's called the 3D shell. All right. I skipped over the first shell. The first shell only has one part to it. So it's called the 1s shell. Now, one thing that's true about all these shells is we're about to get into where in an atom are the electrons, what shells are getting taken up. So when we do that, it turns out if we want to know the location of these electrons, the best shells for an electron to be in is the closest in shell. So when we start using these shells in a little bit, it turns out electrons are going to fill these shells from close in, I should say. Make that better. Close in to the nucleus to further away. All right. So really, we're going to want to know, well, in an atom, where are the electrons? Are they in the first shell? Are they second shell? Are they in both shells? And the way that we're going to know that is we're going to start putting in electrons, and we're going to try to figure out what shells have electrons in them. And as I just wrote, basically, we're going to start with the closest in shell, and we're going to work our way out. We're going to work our way out. So we'll fill up the first shell, the 1s shell. And then you go a little further away, and then you run into the 2s. And then after you fill up that shell, you'll fill up the 2p. And after you fill up the 2p, you'll go to the 3s. And then after the 3s, you'll fill up the 3p. That's a 3 there. That's a lot to read. That's a 3. All right, so you're going to start in the beginning, and you're going to work your way out. So we'll always start in the inner shells, and then when they get full, we'll move our way out. Okay, so it'll always be 1s, and then 2s, 2p, 3s, 3p. Now, you might guess, oh, the next thing I'm going to fill up is the 3d. But it turns out these shells, they kind of get mixed together when you get further away. So the next shell actually is not the 3d level, okay? Actually, the next one that's going to fill up the next shell is actually part of the fourth shell. It'll be the 4s level. All right, so you actually will go 3d, 4s, 3s, 3p, 4s, 3d. Then after 3d, you go to 4p, and so on. So you notice it's starting to get a little confusing, right? We're going to start in the closest in shell and work our way out, but it's a little bit complicated to know what order of these shells should be filled in. So there is a way to help you. And the way to know the order these shells get used is something called the diagonal rule. All right. So we're going to practice this in just a minute, but let me explain it first. If I want to know where are the electrons in an atom, and I want to know what shells are getting used, this tells me the order to use these shells, okay? The order the electrons go into them. And the way it works is basically you start at the first arrow and you go down it. When you get done with that arrow, you move to the next arrow and you keep on going. So the first thing I'm always going to fill up, the closest in shell to the nucleus, is the 1s shell. Now when we fill that shell up, we're going to go down the next arrow. So move over to the next arrow, go down it, you'll fill up the 2s. After you fill out the 2s, then electrons start going into the 2p and then the 3s. When you get to that end of that arrow, you start going down the next. So after 3s, it's going to be 3p, 4s. Oh, what are we going to do next after 4s? Hit the next arrow, 3d, 4p, 5s. So when you get to the end of one arrow, you move to the next arrow and you follow it all the way down, and then you go back. So then it'll be 4d, 5p, 6s. All right, this might make more sense when we practice in a minute, okay? Now there's one more thing I got to tell you, and that is, well, I know I'm going to use the 1s level first, and then I'm going to use the 2s level, and then I'm going to use the 2p and the 3s. But how many electrons can these levels hold, these subshells hold? Well, it turns out anytime you see an S, S's hold a maximum of 2 electrons. P's hold a maximum of 6 electrons. D's hold a maximum of 10 electrons. I don't know if we'll ever get to this, but if we ever have to use an F will go to a maximum of 14 electrons. So when one level is full, you move to the next level. When it's full, you move to the next one. And again, these are really called shells or subshells. When one subshell is full, you move to the next subshell, and you keep on going until you've put in the electrons. All right, so that's the basic idea. We're going to do some examples. I'm going to flip over to the next slide to do them. we're going to basically figure out where are these electrons in an atom. What shells have electrons in them? How many electrons are in these shells? Why on earth do we care? Who cares? Well, I tell you why. Because it has to do with the way atoms behave. So if you want to understand the way atoms behave, you have to know where the electrons are. And that's kind of what we're doing. All right, so with that sort of explanation, maybe it'll help. Maybe it'll make a little more sense if we do some examples. So let's flip over and we'll do some examples. Okay, let's do a few examples. Tell me where the electrons are in an atom. Where are they located? What shells are they in? So there's going to be two things that are going to help us with that. One is we've got our periodic table. So having a periodic table, that's going to help us. And then the other thing we got is this diagram right here. Again, this is sometimes called the diagonal rule. So it tells us the order these shells are going to fill up. All right, so we're going to look at some elements, and I'm going to start with, we'll just start with element number 1, which is hydrogen. And I want to figure out where are the electrons in hydrogen. So what shells are the electrons in hydrogen? So before we can do that, we need to remember a couple things. So first off, hydrogen is element number 1. Since it's element number 1, that means it's got 1 proton, which is fantastic to know. But for right now, we're focused on the electrons. It also has 1 electron. So there's 1 electron in hydrogen. All right, so I want to figure out where that 1 electron is, okay? So let me remind you, we're going to use this diagram. So we're going to fill up, we're always going to start with this level. We'll fill up the 1s level first, all right? And let me also remind you, S's go to a max of 2 electrons. P's go to a max of 10. 6, I misspoke there. P's go to 6, D's go to 10, and then F's can hold up to 14 electrons. Now for hydrogen, it only has 1 electron. So where's it going to be? It's going to be in the closest in shell, which is called the 1s shell. So the way I would show you where it is, the way I would kind of tell you where it is I would write something like this. 1s1. What the heck is that? Well, this is called an electron configuration. It's just a fancy way of saying, tell me where the electrons are. Electron configuration. Oh, that's a little hard to read there. Maybe I'll try to rewrite it real quick. An electron configuration. Configuration. All right. So it's basically a fancy way of saying where are the electrons in an atom. Now, what does that symbol mean? Well, this number here, the big number, that's the shell I'm talking about. So hydrogen's electron is going to be in the first shell. It's going to be in the S part of the first shell. What's the S? Those letters kind of go along with subshells. And then the exponent is how many electrons are in that area, in that shell, the number of electrons. So hydrogen, it's only got 1 electron. Where is its 1 electron? It's in the first shell. So we would write out 1s1. 1s1. All right, let's see if we can do some more. Let's do a few more. All right. So I'm not going to obviously do every single darn element on the periodic table. We're going to skip around a little bit. Okay, so let's move on to lithium. So lithium, if I asked you about lithium, it's right there, and it's a little hard to read because I wrote on the periodic table there. But lithium is element number 3. That means it's got 3 electrons. Tell me where lithium's 3 electrons are. So let me erase this. We're going to put them in, and we're always going to do the same pattern. There's never a different pattern. The first thing that fills up, the closest in shell to the nucleus, is the 1s shell. Go down that diagonal. All right, now when we get to the end of that diagonal, we're going to see that, we fill in the 1s level. But remember, S's can only hold 2 electrons. There's actually 3 in lithium, right? So 2 of them can fit in this 1s shell. That's the first 2. But that ain't all of them. There's still 1 more to go. So we got to start using another shell. So when the 1s is full, we're going to go down the next diagonal. we're going to fill up, we're going to end up using the 2s shell. 2s will be the next level to fill up. Now, there's only one more electron to go. And that one electron is going to be in the 2s shell. So this is how the electrons are arranged. 1s2, there's 2 in that level. 2s1, there's 1 in that level. All right, so that's called an electron configuration. Where are the electrons in an atom? Why do we care? Because it's going to help us understand how atoms behave. We're going to get to that in the next lecture, actually. All right, let's do a couple more. I'm going to skip ahead a little bit. Can't do every darn element. Let's do oxygen. Oxygen. Where are the electrons in oxygen? Well, first off, you got to know how many there are. There are 8 electrons. It's element number 8. That means it has 8 protons and 8 electrons. All right. Let's see if we can figure out where they are. So we're going to start off right here. You're going to fill up the 1s electron. 1s. Okay. So 1s level, I should say. So we'll write 1s, and then it's going to be 1s. I guess it'll be 1s. 2 will be the first thing to fill up because S is going to only go to 2. When that 1s is full, we got to move on to the next level. We'll fill up 2s. That's the next arrow. 2s. S's can only go to 2. 2s, 2. And then we'll move on. Then, because we got to go to 8, right? And how many have I put in so far? I've put in 4. 2 in the 1s. 2 more in the 2s. There's 4. So after 2s, the next thing we're going to fill up is 2p. Now, p, actually, 2p, any p, has room for 6. We got 4 more to go. So all 4 of them can fit in that level. 4. Okay. All right, with that, we're going to try one last one. Now, I'm going to see if you can, or kind of getting the idea of this. Let's do it. Maybe you can help me out. We'll do a few practice questions along the way. Let's try one more for today. And let's see if it's making sense. Okay, so let's move on. Let's do sulfur. Sulfur's right there. Sulfur, it's number 16 on the periodic table. There's 16 electrons. We're going to figure out where its 16 electrons are. Okay. All right. So we're going to start always in the same spot, right here. Go down the 1s. S's hold 2. 1s2. Move on to the next level. 2s. 2s2. All right. So far we've only put in 4 electrons. Man, we got 12 more to go. All right, question number 1. After you fill up the 2s, what's the next level you're going to fill up? Oh, it should be the 2p. 2p. All right, so it'll be 2p. And p's can go to 6. P's can hold 6 electrons, so we're going to need all 6 spots. All right, let me ask you question number 2. If you look at what I've done so far, how many electrons have I put in? Oh, hopefully you know it's 10. Yeah, it's 10. Okay, because 2 and 2 and 6 makes 10. So we got 6 more to go. We're stopping at 16 this time. So after 2s, we're going to fill up, 2p I meant. We're going to do 3s. So s's again go to 2. All right, now that gets me 12, so we're getting close. We got 4 more to go. All right, one more question. After 2s, maybe I'll erase this a little bit, or maybe I'll just do it again. All right, so we've done this, and then we went down this, so now we're down here. After 2s, help me out, what's the next thing you're going to fill up? Oh, should be 3p. You're going to fill up 3p next. You're going to start going down the next arrow. And all 4 of our electrons can go there. So it'll be 3p4. All right, so that's called the electron arrangement. Those are the shells with electrons in them. That's how many are in each shell. All right, so we're going to actually do more of these next time. So if you're not 100% perfect on this yet, you know, we're going to be talking about this in lecture 20 as well. So If you have any questions in the meantime, let me know. You can give me a phone call. You got my phone number. You can send me an email. I got Zoom office hours. I'm here to help you as always. And with that, we're going to do one last practice question actually. Wait for it to come up. Okay, with that, we're done. I will see you next time. Have a great day.